So the dimensions of the rectangle are shown. What's the perimeter in units of the rectangle? So what's the perimeter of this guy? Well, how do we go about doing that? What is perimeter? What is perimeter? We add up all the sides. So we're going to do 3x plus 8 plus 5x plus 2 plus 3x plus 8 plus 5x plus 2. And then we're going to combine our like terms. So 3 plus 5 plus 3 plus 5 will give us 16x. 8 plus 2 plus 8 plus 2 is going to give us 20. All right, number 9, rewrite the expression. We're going to distribute this negative. So that's going to give me x cubed plus 2x squared minus x plus x cubed minus 2x squared minus 6. Now we're going to combine our like terms. So we can combine x cubed and x cubed, which will give us 2x cubed. 2x squared minus 2x squared will just cancel. We've got this negative x just chilling. And then we got minus 6 just chilling. All right. So this is where it gets a little interesting. We're actually going to start solving. We're not doing logs. So you can go ahead and like kind of scratch that out. That's actually in Algebra 2. We're not going to talk about it in here. So I used to teach Algebra 2 in this worksheet. I pulled it from there. So if the bases are equal, the exponents are equal. Okay, so if we have 3 here and 3 here, we're going to drop the base and we're just going to look at the exponent and set them equal to each other. So x would equal 4. On the next one, since the bases are the same, we drop the base, set the exponents equal to each other. Can we solve that? Yeah, what do we do? So x equals 3 because we would subtract 2. And so x would equal 3. Same thing on the next one. We're going to take negative 2x, set it equal to 6. Divide by negative 2. So x would equal negative 3. Go ahead and try 4, 5, 6. All right, what do we do? Get rid of the 100s. Okay, now what? Minus 1. And then what? Divide by 3. So that's going to give me x equals 1/3.
Wait. I did 1 minus 1 to get rid of the 1 on the right side. And to subtract the 1 from the 2. So I got 1 equals negative 75. 3x, and then I divide by.
How would you do this? All right, so you did 2 equals 3x plus 1. You moved 2 to the other side. Okay, so 1, you subtracted it. That would have given you 1 equals 3x. We divide by 3. No, because it's attached to the x. We want to get x by itself. We want to get x by itself. All right, on the other side, or on number 5, we're going to take 4x minus 2 and set it equal to x plus 4. Go ahead and take a moment. Try this one. All right, so we subtract x, and that's going to give us 3x minus 2. We're going to add 2, so that's going to be 3x equals 6. We're going to divide by 3, so x will equal 2. Okay. On the next one, same base, so we're going to have 10x equals 100. We're going to divide by 10, so x would equal 10. Okay, now, when bases are not the same, you have to change one side or the other to make the bases the same. So we got a 3 over here and we got a 9 over here. The bases are not the same. Okay? If we want them to have the same base, we need to think of a factor of that number. So what are a factor of 3 and 9? 3. Can I take 3 and raise it to some power to get 9? Is that going to be 3? What? 3 times 3. So 3 squared would give me 9. So 3 to the x plus 5 equals 3 to the second power. Now are the bases the same? Yes. So we're going to drop the base and we're going to set the exponents equal to each other and then solve. So this will give me x equals -3. Okay, so the first thing you got to do is check the base. And change it if you need to. Then you're going to set the exponents equal. And then you're going to solve. Okay, I'm going to give you a second. Are the bases the same? No, but we need to have a factor of 4 and 64. So what's a factor of 4 and 64? Let's say we take 4. Can we raise 4 to some power to get 64? If we take 4 and we raise it to the 8th power, does that give us 64? Let's check. We go into Desmos and we say 4 raised to the 8th power. Does that give us 64? What about the 3rd power? Does that give us 64? Yes. So we can rewrite this as 4 raised to the x minus 2 equals 4 to the 3rd. Does everybody see how that 64 went to the 4 to the 3rd power? Okay. Now, since the bases are the same, we drop the base. And we set the exponents equal to each other. Now, we're going to solve. X equals 5. Questions over that? Okay. The last one is a little trickier. 8 and 4 have a factor. They have multiple factors. They have 2 as a factor. They have 4 as a factor. Can I take 4 and raise it to some power to get 8? 4 raised to what power would give me 8? 4 to what power would give us 8? There's not one, right? So what we're going to do is we're going to drop this down to the base of 2. And 2 to what power would give us 4? 2 to what power would give us 4? 2. So we're going to have 2x plus 1. Over here, 2 to what power would give us 8? 3. Okay. Take a second. Look if we can take the exponents and set them equal to each other. We're going to distribute that 2. And that's going to give us 2x plus 2. And then we're going to solve. So if we move that to the other side, x will equal 2. I'm not going to sit here and say that this is really easy, because if you have a hard time, we have to make sure that it's the same base on both sides. But I'm not going to sit here and say that's really, really easy. Sometimes this is difficult because of like knowing your factors and knowing what to the second power, what to the third power makes that number. So I need you to try 4, 5, and 6. Make an attempt. Oh, let's stop. On this first one, we got 2 to the x equals 4 to the second power. I can rewrite this as 2 squared times 2. Now I'm just going to drop the base since they're the same now. And so x is going to equal 4, because 2 times 2 would give us 4. Okay. On the next one, We don't have the same base. 25 to what power would give us 125? Well, that's not going to work. What if we did 5 squared for 25? 5 to what power would give us 125? Okay. So this is going to be 5 to the third times 3x plus 2. Now we're going to take what's in the exponent, set it equal to each other. So you've got 2 times x minus 4 equals 3 times 3x plus 2. We're going to distribute. So that's going to give us 2x minus 8 equals 9x plus 6. And then move the 2 to the other side. And that's going to give us 7x. I'm going to move the 6 to the other side, and that'll give us negative 14. If I divide by 7, that'll give us x equals negative 2. The last one, we're going to change both of the bases because we can't raise 9 to some power to give us 27. So 3 to the second would give us 9. And 3 to the third would give us 27. Okay, now since they're the same base, I'm going to set them equal to each other. And distribute. And then solve. Questions on that?